Hello student, welcome back to Power Electronics. This is Raid Al Malki. Today inshallah we will go through lecture number 10. Now in the previous lecture we have discussed the DC choppers and we found out everything about the buck chopper, the principle of operation, and we analyzed the circuit and we have taken some formulas in order to find some values, right? And today, inshallah, we will go through the boost chopper. Okay, it is in chapter 6, and you can find it in the handout. And chapter 6 in the textbook, of course. Now, this is the buck. Sorry, the boost chopper converter. Boost chopper converter means we are going to boost the voltage up. We are going to step up the voltage, right? We are going to step up the voltage. Of course, the concept is still the same here. We have we have a system. Sorry, we have a system here. Now this is our system. Again, the same thing, the same concept. We will convert from DC into DC, right? We have V out here, V in, sorry, and here we have V out, right? So this is V in, this is V out. But the V in signal is like this. This is V in. The V out signal is like this. So there is we stepped up the voltage. So we boost the voltage up. We boost the voltage up. So inshallah we are going to outline introduction, and we will go through boost chopper and some examples. Okay. Now let us see the circuit here, شباب. Let us see the circuit. Now we know from buck, شباب. Let me write it here, شباب. The buck is the buck formula is V out is equal to Vs multiplied duty cycle percent, right? Now in boost, inshallah, we will drive the equation again. Boost, we will find that the V out is equal to Vs or Vn over 1 minus duty cycle percent, right? So inshallah we will drive the equations here now. Now let us see also the diagram for or the circuit, the electrical circuit for the buck, يا شباب. Now this is our buck. We have here supply voltage Vn, and then we have a switch, power MOSFET switch. Then we have diode here. Sorry. Then we have our شباب, low pass filter. This is low pass filter with the capacitor, with inductor, and we have here our resistive load, and this is V out. This is Vn. Now what is the difference between this circuit and the boost? This is buck, this is boost. Can you see, شباب? We just only change the location of the inductive load. Can you see the inductive load here? Now it comes here, right? And in the beginning, it is near the load, right? And the diode here, it was here, and diode here. Now the location of the diode is changed. The switch is here. So we can say, if you understand the buck, شباب, we can just only do like this. So the inductor, you will take it مكان switch, in place of the switch. The switch, you will take it in the place of diode. The diode will take it in place of the inductor. So the inductor is here. The inductor is here. We'll take it in place of the switch. So this is the inductor, and the switch, you will take it in place of the diode. So this is the switch here, and the diode will make it through the inductor. So the inductor is here. the diode is here. Okay, so this is the boost converter, the boost converter. And again, if we need to analyze this circuit, we need to make sure that you understand the shabab, the steady state conditions. We need to make sure that the T is the period and the time closed, again, D multiply T, and the open for the switch is 1 minus dt, right? Of course, the inductor current should be in continuous current mode, CCM, right? The capacitor is very large also to hold the constant at voltage V out. The components are idle, we don't have losses. We will assume there is no voltage drop, there is no losses, and the inductive load here has a resistance of zero ohm. Okay. Now we can just go for the waveform now, but let us do the analysis and let us reach to our formula. Okay. Now this is when the switch is closed. Now here يا شباب our switch, remember? Now here our switch. So the switch is closed. Now let us see the how we can analyze. Now the diode here is open. Why is that? Because it is reverse bias. Now let us see why it is the reverse bias here. Now when the switch is closed, okay, we have positive here. This is our convention. This is our convention here, positive, negative, and we have here positive, negative, right? Okay. Now we have also here positive, negative. Now what will happen? I'm going to change the color. Now this positive, negative here, shabab, this positive and negative here, it will be the same as what? The capacitor, because they are parallel, right? So we will have positive here and negative here. You remember the diode is like this. You remember the diode is like this. So the anode on the right side, the anode on the left side, the cathode on the right side. Now what will happen? Can you see here, shabab? This is closed, right? So this negative will go here. So this negative will go here, and this positive is here, right? So the voltage V anode cathode is negative, then it will act like reverse bias, and it will be like open circuit. Clear? That's why we have open circuit. Now I'm going to erase. Okay, I'm going to erase. Now, so in case of switching or closing the switch here, what will happen? The voltage supply here will, or the current from the supply will go through the inductor, and it will go here. It will charge the inductive load. It will charge the inductive load. So there is no output current. There is no output current here, right? Until now. Now, but there is. I'm confusing you a little bit, but there is. Why is that? Because we have capacitor here. Remember, shabab, capacitor is storing voltage, right? So there is a stored voltage here from previous situations, and this capacitor will act like a source now, and it will supply the load, the load with the current IC. So here IC is equal to what? I output, صح? I out. So in case of switch closed, the inductor here is charging, and the capacitor here will supply the load. Okay, with the small current, of course. Now let us analyze the circuit, and we know that VL يا شباب here, the VL here, the VL, VL is basically equal to VS. Why, shabab? The same voltage here, shabab. So can you see here? This is now here. The positive is here, right? And the negative is here. So it is like this, shabab. It is like this. So the supply is like this. So it is parallel, right? So the supply is parallel. So they have the same voltage. That's why we have the same voltage. That's why VL is equal to VS, and we know VL is L dIL by dt. So our di by dt is Vs over L. It's not negative. They have the same, so it is positive, okay? Now, for solving for delta I, now we know that, of course, this Vs is constant value, and L is constant. That's why di by t, the rate of change of current, should be constant or linear. Charging and discharging, linear. So in case of switch close, we have charging current, right? So we will concentrate only on the charging current. So if we have charging current, then the slope is known, which is Vs over L, right? The time is already known right here. This time is here known. So we need to find delta, like this, delta IL, right? So delta IL close. So we can find it that delta IL close is basically when we multiply by what, shabab? By the time close, right? So yeah, delta, so we need to reach this one, right, shabab? So delta I close is equal to T on, because we are using T on, multiply Vs over L. And we know T on is basically duty cycle, multiply T, multiply Vs over L. Right, shabab? So yeah, so if we need to find ya shabab, so Vs over L, so we can just find delta. So we can say that delta I C close mean duty cycle, multiply T, multiply Vs over all L. So this is the same thing here. Okay, so this is when the time is closed. Now this is the formula of the closed switch. Of course, we need to reach to steady state, shabab. Remember, delta IL close plus delta IL open is equal to 0, right? So this is steady state. This is our assumption, right? So let us go for the open circuit. And this is for the close, yeah. This is for the close switch. Now for the open switch, shabab, okay, for the open switch, we know that now this is open switch equivalent circuit, okay. Now why, if we have open switch, now we have here, we have here switch, right? You remember? It is open, so that's why they remove it. Now our diode was like this. Now why it is acting like forward bias now? Because we have now the inductive load is discharging. That's why it will be the polarity will flip, and we have positive here and negative from the supply, right? So that's why the diode here will act like a closed wire, yeah, and it will act like forward bias, and we have closed wire. Now let us analyze the circuit. Now if we have open switch here, then Vs will allow current to move through VL. Now VL, ya shabab, is already charged, right? Is already charged when the switch is closed. Now the switch is open. So what will happen to the VL here? It will discharge, right? It will discharge. Now can you see here, ya shabab? Now we have minus here minus, sorry, here minus, here we have plus, here minus, here we have plus. What do I mean by this, Shabab? Huh? What do you think? Yes, this is two sources together. So we can add Vs plus VL now. So we have two sources. One of them is Vs, one of them is VL, because VL is going to discharge, right, the current. That's why we have, in this case, we have two sources are going to supply the current, the huge current, into the load. And of course, we have current through the inductive load, the capacitor here, but it will not affect the output voltage because this is very huge capacitor as we assumed before, right? So let us do now the analysis here. Now let me do the analysis here, Shabab. Now we said we have two sources, right? So let me do it here. So Vs, here, Shabab, on the right side. So Vs, V out is basically Vs plus VL. So VL is equal to Vs minus V out. Yes, correct. So this is our formula. Okay. Now we have two sources, as we said. Now this is VL. We know that VL is L multiplied by derivative, the rate of change of the current, and then the formula is like this. Okay. Now this is again the discharge current, and the discharge current is known. The slope is known, which is this one. The time is known here, and you need to find delta IL open. Okay. Now we need to multiply this value here by the duty cycle by T off. We need to multiply by T off. So yeah. So delta IL open is equal to what? Equal to Vs minus V out over L multiplied by what? 1 minus duty cycle percent and multiply T. So if we can find here, Shabab, you will find that delta IL out is equal to what? Is Vs minus V out 1 minus duty cycle multiply T over L. Now this is our formula for the delta IL out. Sorry, more out, open. Okay. So if we find here, Shabab, at steady state, we can add them together. We will add them together in the previous slide. We will add them in the previous slide. Okay, we will add them here. Forget about this one. Now we can add steady state VIL close plus VIL open is equal to 0. Now VIL close is basically duty cycle percent multiplied by T multiplied by Vs over L, right? This is over L, and plus 1 minus duty cycle percent multiply T multiply Vs minus V out divided by L, right? This is equal to 0. Now we need to remove T here from T here because they are common factor, so we can remove L and also L. Now we remain with Vs duty cycle percent plus Vs minus V out minus Vs duty cycle plus V out duty cycle percent equal to 0. Okay. Now, again, we have something to remove. We have minus Vs DC. We have plus Vs DC, right? Now, what is the rest? We can take the Vs out, يا شباب. So Vs is equal to what? V out minus V out DC, or we can say, you can take common factor يا شباب. Now V out 1 minus duty cycle percent. Okay, now we need to find V out. This is the most important شباب. V out is basically Vs over 1 minus duty cycle percent. So this is our this is our derivation here for the formula. Now this is the same formula that we said before. See Vs over 1 minus duty cycle, right? So this is the same thing here. So this is the same thing here. V out equal to Vs over 1 minus duty cycle percent, right? So this is the derivation of the formula here. Okay, guys. Now for the waveforms here, we know that again the duty cycle for the voltage of the gate of the switch is 50% on, okay, and 50% is off. 50% is on and 50% is off. So this is 1T, right? From here to here we have T. From here to here we have T on, and from here to here we have T off, right? Okay, now we need to see the output voltage, the output current. Now let us see the output current. Now the output current when the switch is closed, right? When the switch is closed, current IL here, right? Now, but the capacitor here, it will discharge. It will discharge, and the current will go to the output. Now, from where the charge entered the capacitor? From the previous. So the previous situation, let me do it here and you will understand. Now in case of closing in case of opening the switch, what will happen? So as we said, we have two voltages, right? It will add together, then it will release with the inductive load here will release also its charges. Then it will go through the capacitor and through the load, right? It will be huge current. Now this at this stage, so when the switch is off, capacitor is charging. So when the switch is closed, capacitor will release, right? The capacitor, when the switch is closed, capacitor will release to the load, right? And here also we will have charging of the inductive load. So I out is releasing, right? I out is releasing. So we can say when the switch is closed, then we have release current. When the switch is open, then we have two currents here, two voltages added together, then we have a huge current. Then we will have current through the output, so it will be charging, right? And then it will be discharge, charge, and so on. Okay, now let's go for let me change this, shabab. Let me change this. Sorry. To I L. We need to see IL. So IL, when the switch is closed, let me do it here. When the switch is closed, so we said the IL will rotate here, right? So it will be in this direction. Now, so that means it is charging, right? So when the switch is closed, that means it is charging. When the switch is open, of course it will discharge, right? Charge, discharge. Now let's see the I diode. Now when the switch, let us do the analysis for the current of the diode. Now the current for the diode, when the switch is closed, okay, when T is on, then what will happen? We have rotation current here. Do we have current here in the diode? No, we don't have. That's why it is 0. So when the switch is on, we will keep the current 0. Now when the switch is off, means it is open, what will happen, ya shabab? Then the inductor the inductor and the voltage current will add together, voltages will add together in order to produce high current, so it will go up, right? So it will go up. Yeah, it will go up. Yeah, the value go up, and it will go to the resistive load. Then it will because the inductor is going to release its current, so from up we can go down up to here, then we go down, then we go up like this, and we go down like here, and we go like here. Now this is one cycle, this is one cycle. Now this is for the I diode. Now the V out, or the V diode, V diode is the same as before. So if we don't have current, so it will be, if we didn't have current, then it will be like this. It will be 0, because it's, if we have current, then we have 0 voltage, because it will act like a wire. If we don't have current, then we have the voltage, the negative side. Now for the VQ, now we did not draw the V out. V out is important, so we will release. Oh, sorry. Okay. V out is more important, so we will remove here. We will draw V out. Now V out, let us do the analysis here. When V out is what, shabab? When the switch is closed. Do you have V out? Yes, we have. Is it up or down? Because it will be down a little bit, because what, shabab? Because of the capacitor. The capacitor will release. It depends only on the voltage of the capacitor. So it will release, so it will go down a little like this. Okay, then it will depend on the V out will depend on the 2 voltages here, then it will go up. Of course we will have ripple. We should have straight line, but still we have ripple. We will have ripple at the output. Okay, now for the for the switch, of course, the switch, when the switch is open, when the switch is closed, then there is no voltage, right? When the switch is open, then we have voltage, of course. Now let us see the V source at 75%. So 75% is like that we have done before. It's like this, and it will go to 0. It will go up again. This, it will go to 0. And this is for the VS. What about the I out? I out, it will discharge first. Or I out, we used red. It will discharge and then charge a little bit. Okay, why it is discharged? Because we have only the capacitor current. Why charge? Because we have the sources current. It will do like this. Okay, now what about the inductive load? The inductive load, of course, it will charge as the inductive IL, so we use green. The inductive IL is just increasing, sorry, just basically increasing like this, and it will decrease, it will release after switch is off, then it will increase and then release, charge and discharge. Okay, this is all about our lecture today. You can find the formulas here from your book, ya shabab. These are the formulas from your book. Again, the same formula for this is for boost, right? Please look at examples 6-4 and 6-5 in your textbook, and refer to this video in order to see more examples. Now this is all about the post chopper, post, so we need to change this one is post, again here, post, again here, post, again here. This is for post, huh? Post. I will keep all my remarks, ya shabab, and I will send you the slides. Thank you so much for coming and attending. Thank you so much for attending this lecture, and stay safe.